Hi guys, how are y'all doing tonight?
Good.
Okay, well, tonight we're wanting to see if we can use this session as kind of like an example for our university. So I'm going to read y'all this consent form, and if you do consent, just type in that you consent or tell me that you consent somehow. And if everyone does, then we can use it, and if anyone has a problem with it, we won't distribute it. So I hereby consent to the use, reproduction, editing, and or broadcast by Texas Woman University of any and all photographs, video recordings, and audio recordings of me taken by or on behalf of Texas Women's University from this day without compensation to me. All negatives and positives, prints, video recorded images, and audio recordings shall constitute to the property of Texas Women's University solely and completely.
I consent.
Matthew, can you tell me that you consent? Just so we're clear. All right, thank you. Okay. Well, we'll go ahead and get started. So, have any of y'all taken your Chapter 2 exam yet? Okay. Well, this session is basically just a review session where we'll go over anything that y'all don't fully understand, as well as just some basic concepts of Chapter 2. So to start off, is there anything that any of y'all would like to go over or just talk about? Okay, Nancy, what would you like to go over? Yeah, you can write it. Okay, so in this it's just saying the absolute value of x minus 3 over 2 is less than 5. Now, does anyone know how to solve this, or would anyone like to take a shot at it?
I think you should move the 5 over and equal it to 0.
Okay, does anyone agree with her? Or does anyone have any other ideas as to what we might do? Multiply both sides by 2. Okay, actually, since this is an absolute value problem, what we have to do initially is turn it into 2 problems. So we're going to keep it as x minus 3 over 2 is less than 5. That's going to be our first inequality that we're going to solve. But also, since it's an absolute value, and absolute value is distance from 0, we have to set it equal to -5 because the absolute value of -5 is the same as the absolute value of 5. Because whenever we deal with absolute value, the sign is it's meaningless as to what its absolute value is. Now, the only difference here than what we would have with an equation is that, like if it was an equation, both of them would be set as equal to 5 and -5. But since it's an inequality and we're using the opposite, so -5, we have to change the orientation of our sign. So rather than, so we've got x minus 3 over 2 is less than 5, but we also have x minus 3 over 2 is greater than -5.
Did you change the inequality because it says that x minus 3 over 2 is less than 5 and -5 is less than 5? So that means 7 minus 3 over 2 will be greater than? Is that why you changed the inequality sign?
Well, you change the inequality. Basically, whenever you're dealing with absolute value, if you take the absolute value bars off and then you leave the original inequality as is, but then whenever you use the opposite number, you change the inequality. So for instance, if the original inequality was x minus 3, or the absolute value of x minus 3 over 2 is greater than 5, then whenever we did that, or whenever we take the absolute value off, it's still going to be x minus 3 over 2 is greater than 5, but then it would be x minus 3 over 2 is less than -5.
Okay.
So I mean, it's really just solely dependent on what your original inequality is, and just know that you're going to use the opposite whenever whenever you put the other one down there.
Okay.
Okay, so Matthew, I see that you have a question mark. Are you confused about anything? Oh, okay. Okay, so from here, we're just going to solve it as we would any other inequality, any other equation. So what are we going to do first?
Move the 5 over?
No, we're not going to move the 5 over. We need to try to get rid of this fraction over here.
So do we multiply by 2?
We're going to what?
Multiply by 2?
Right. We're going to multiply by 2. So we'll just write a little 2 here. And just know that this is going to be times 2. So the 2's will cancel. And then we're left with x minus 3 is less than 10. And x minus 3 is greater than 10. Or -10, sorry. Okay, so now what are we going to do?
Subtract the 3 on, add the 3 on both sides.
Right, we're going to add the 3 on both sides. So plus 3 here, plus 3 here, plus 3 here, and here. So we've got x is less than 13. And x is greater than -7. So how would we write our answer? Like if we're going to use the parentheses and the domain of what our answers can be.
Would it just be parentheses -7, comma to 13, or would it be, do we have to do the union? Since it's an and? It's just an and we do -7 to 13, both parentheses.
Okay. What you said the first time is right. So it's just going to be, yeah, or Matthew, lowest to highest. So I'm going to type it out. It's just going to be -7 and then 13. Because -7 is the lowest number that this can be. Well, not technically. It's basically any number that's higher than -7 and any number that's lower than 13. Those answers are going to make your original inequality true.
Okay.
Now, what if our original inequality had the or equal to? Yes, Matthew, that's one way that you could write the answer, but what I wrote above that is another way. But anyways, as I said, if our original, and just look up here at the top at what Matthew wrote originally, what would our answer be if it was originally less than or equal to?
Would it be comma negative? Are you talking about the domain?
Yes.
Okay. Parentheses negative infinity to positive infinity. I mean, parentheses negative infinity to -7 bracket, then the union, then bracket 13 to positive infinity.
No, that's what it would be if the original sign was reversed and then or equal to. But basically what I'm just trying to get at is if that you have an or equal to, like in this case, if it was, you know, the absolute value of -3/2 is less than or equal to 5, you would get the same answer as we got. It's just you would use brackets instead because the -7 and the 13 would be included.
Okay.
Okay. So does that kind of clear things up, Matthew? Okay. And can anyone tell me why we set it as 5 as well as -5? Like why we turn it into two inequalities?
Because of the absolute value.
Right, but I mean, can you tell me why the absolute value requires us to do that?
Because -5, if you take the absolute value of -5, it'll be +5. If you take the absolute value of 5, it'll be +5.
Right, and that's simply because absolute value is basically the distance from 0. So that's why your negatives and positives would have the same thing, and that's why you have to turn it into two equations. So, okay, go for it.
You did. What about you?
Yeah, I see what you mean. Basically, whenever you're going to use the union, like if we use the example that we just did, but if originally the absolute value was greater than 5, then what our answer would have been was
oh shoot. Uh-oh. Don't leave, guys. Did you not do so good the last test? I don't think you come on tonight. Yes, unfortunately.
Okay, sorry guys, my computer shut off. Matthew, did you get any answer or confirmation on when to use the union or not?
Don't you use the union when it's greater than or equal to or less than or equal to?
Okay, I only caught the tail end of that. Could you ask the question again?
Don't you use the union when it's greater than or equal to or less than or equal to?
No, you use the union, like for instance, if like using our example that we used earlier, it like how it was, you know, x is greater than -7 and less than 13. It's like those agree with each other, so we could write them as is. Now, if we had something that was like x is less than -7 and x is greater than 13, then we would use the union. We would say negative infinity to -7. And then union 13 to infinity. Does that make sense?
Mm-hmm.
Okay. So like I said, it's really only when basically it's like different number sets. Like the reason why we didn't have to do it originally is because it was x is greater than -7 and x is less than 13. Well, those, I mean, they fall under the same category. Like, you know, -7 to 13, that's going to be your answers. Whereas in this case, I mean, you have everything up to -7 as well as everything after 13. So that's why you would use the unit.
Oh, okay.
All right, now I see this 2 plus 3i plus 7 minus 2i. So were one of y'all wanting to do this problem?
I wrote it because someone said that they had problem with, they wanted to work on 2.3, 2.4, and 2.5, and that was just the problem that I thought of, and then you left, so I just wrote it until you came back.
Okay. Well, this one, y'all understand how to do this one up here? The 2 plus 3i plus 7 minus 2i? Okay. So basically, the key here is what we're doing to it. So right here we have a plus sign, and just remember that anytime we have a plus or a minus, it basically means to just combine like terms. So for instance, we've got a 2 and a 7, so we're going to combine those. We're going to add them. So that'll leave us with 9. And then we have a 3i and a -2i. So if we combine those, we're left with just I, or 1i. So the final answer to that would be 9 plus I. So do you see how we did that, Matthew? Yeah, I mean, anytime you have any type of polynomial, even if it has imaginary numbers in it, variables, if you see a plus or a minus, it means just combine like terms, but do it according to what your sign is telling you. So in this case, it's a plus, so it's just add them. Now, if this was a minus, we would do 2 minus 7, which would give us -5, and then 3 minus a -2i, which would basically just be 3 plus 2i. So if this was a minus, it would be -5 plus 5i. Okay. Basically, however many different types of variables you have in there. So in this case, we have a constant as well as an imaginary. So I would call that a binomial. Now, I'm not sure if like your imaginary numbers count as I'm not sure if imaginary numbers count necessarily towards like a degree of a polynomial. But let's just say we have like your original quadratic. You've got like 2x squared plus 3x plus 5. This would be a trinomial because we have an x squared, an x, and a constant. Or if we wanted to say, you know, an x to the 0 power. But we don't write x to the 0 just because anything raised to the 0 is 1. So basically, I mean, it's just, okay, well, you know it's a quadratic if and only if you got this x squared. So for instance, even if you had 2x squared plus 5, although this is a binomial, it can still be a quadratic just because you can rewrite that as 2x squared plus 0x. This pen's really messing up. Plus 5. So just think of quadratics as anything with an x squared in it. And from there you can do the quadratic formula always, but you can also see if you can factor, see if you can complete the square. Honestly though, if I were you, just make sure you fully understand the quadratic formula, because that's what you can use on every single quadratic and you will get the correct answer. Okay, so we've done addition with imaginary numbers. Now let's do one where we multiply. So I believe we had 2 plus 3i and then we'll do times 5 minus 2i. Yes, we can definitely work on radical equations after this. And Matthew, the quadratic formula is negative b plus or minus. Yes, that's right. It's just going to be negative b plus or minus the square root of b squared minus 4 times a times c all over 2. And so here we've got, they're the same numbers as we used in our
You solve it by factoring, right? Like the same way you would factor if it didn't have the I, such as 2x plus 2 times 2x plus 3. Yeah, FOIL, that's what I meant. I couldn't figure out what the word was. I squared always equals -1. square root both sides since the x has since the 49x is together. So you can square root both sides and then you get 7x equals 1. And then you divide by 7 on both sides. So you get x by itself, and then it'll be x equals 1 over 7. I think. You could divide 49 on both sides and still, you could divide 49 on both sides and still square root it and get the same thing, I think. You get the same thing. Yeah, it's plus and minus.
Okay, what was the original problem here? (49x squared minus 1 equals 0).
Sorry, I said it, but I was talking to myself.
Okay, so we got 49 x squared minus 1 equals 0. So what we can do is just, it's a relatively simple one. It's not that complex of a quadratic. We can just add 1, divide by 49, and then take the square root of it, which is, I think, what y'all did. And you'll get, so basically, at one point, it'll look like x squared equals 1 over 49. Take the square root. These will cancel. Whenever you take the square root of a fraction, it's the same thing as taking the square root of the numerator and the denominator. So we're left with x equals square root of 1 is 1. Square root of 49 is 7. And just remember that this can be positive or negative 1/7. Yes. Yeah, let me clear this page real quick. All right. Okay, so this is very similar to the first problem that we did. So what do you think we're going to do first?
Can't you equal this one to 0 since it has the equal?
No, we still have to set it into two equations because it has to do with absolute value.
So 3x1.
And even if it's greater than or equal to, we still can't set a side equal to 0 because it's still not an equation. It's still an inequality. Yeah, you can work it, Matthew. Okay. The issue here is that you did not change the sign of your second inequality. So for instance, your first one's good, but where you have 3x minus 4, it should be less than -9. The reason you change the sign is because since it's an absolute value problem, just know that absolute value is the distance from 0. Therefore, the absolute value of 9 is the same as the absolute value of -9. They're both 9 units away from 0. No, not the reciprocal. The reciprocal would be 1/9. It's just the opposite. But the math you're doing is all right. It's just instead of this 13, it's going to be a -5. So we'll change that real quick. And 13/3 is as simple as you're going to get it, so that's fine. Okay, and those are right. So you've got x is greater than or equal to 13/3, x is less than or equal to -5/3. And this is a great example of where the union would come into play.
Why would the union come into play?
Because x is everything less than -5/3, therefore it's -infinity to -5/3, and x is greater than or equal to 13/3. Those don't necessarily agree with each other. They don't fall into the same range, so you have to separate them, but you have to put the union in between them.
What do you mean by same range?
Well, you remember how earlier we had x is greater than -7 and x is less than 13? Well, I mean, x, it's like you can use the same x. It's kind of difficult to explain. It's just that in between 7 and in between -7 and 13, that's where your answers are.
Like, x is greater than +13/3 is basically the opposite way of x, and then since it's less than -5/3, they're not like combining; they're separating kind of.
Yes.
Like one's going one way, the other was going the other way. Which one? The other one, the -7 and 13, they were both going facing the same way.
Right. Right.
Oh, okay.
And Matthew, that looks good. It's just you have to remember to put your brackets rather than your parentheses. So it should be, open parenthesis, -infinity to -5/3, close bracket, union, open bracket, right.
Oh. It's because it has the equal to.
Right.
Okay.
All right, you're welcome. That's about all the time we have. Again, I apologize that my computer shut off twice. My email is in the chat box. It's rtally@twu.edu. Just email me with any specific questions that you have in case I didn't get a chance to go over them, and I'll email you back the answer as well as a description on how to get that answer.
Is there another place we can find your email?
Yes, I'll write it again. Just a minute. All right, you should see it in your chat box here in just a second.
Thank you.
You're welcome.
Are we able to leave now?
Yeah, you can leave now. And Matthew, I'm not actually a teacher. I'm a student here, and I will be here next year. And I'm reapplying for the job. It's not set in stone that I'll be here or that I'll get the job. But if I do, then yes, I'll be over online, and I may or may not teach in a class. But if you have any other questions about any other courses that you take, just email me, because I've taken a lot of maths and stuff. And if I can't help you, I'll try to come into contact with someone else who can. And if you can, at any point in your schedule, if you go over to the math lab, the tutors there are really great. So they'll be able to help you with quite a bit. And thank you, I appreciate that. And I'll let Chris know that as well. All right, you're welcome. Good luck on the test next week. All right, you too.